Hey everyone! Um, as you can see, this demonstration video is set up a little bit differently. You have seen one other one, I know, demo video that had this white back screen on it, but it didn't have any narration. But now you can hear me off to the side and I don't have to appear on camera. But really, I did this because just like the other one, this involves some colored water, so this should make it a little bit easier for you to see what's going on. So what we have here is just like a base. This is a critter keeper. It has some water in it. We have a funnel, and then we have, of course, a tube going down into the water. That's just to help the water, help it get in there a little more smoothly. Off to the side here, I have a cup of water that has been mixed with lots and lots and lots of salt. And I use kosher salt because it's a little closer to what you would have in the ocean. Look at that. There it is. All right. So the other thing I've done is I've chilled this just a little bit because the idea here is to simulate the deep ocean currents that we've been talking about in class. So what I have here is a thermometer. I just want to show you that. Hopefully you can see this in the film. It's lit up, right? There. It's right about, let's see, 20 degrees, which is about room temperature. Okay, so this temperature here in our ocean, as it were, is about 20 degrees Celsius. And the temperature here in the ice water, the salty water, is getting down there pretty low. Like 8, around about. It's not really freezing, it's just chilly. Okay. Now, in order to make this easier to see, of course, we're going to make the cold water blue. So I'm going to add this to it. Add a couple of drops of food coloring, just so you can see what's going on. And I've already mixed the salt in just to make this go a little faster. So there we go. All right. So now what we're gonna do is I'm gonna pour this salt water into the funnel, and you're gonna watch and see what happens. So hopefully I can do this slowly enough that I don't mess up what I'm trying to do here. So just keep your eye on the ball there. Ooh, I'm dripping it all over the bottom of that. There we go. All right. So as we discussed in class, not only is the water in my cup here more dense because it's colder, it's also more dense because it has salt in it. So you're going to use that demonstration, and notice how cleanly it stays at the bottom. I mean, it doesn't mix at all. Anyway, so when you go to do Explore, this is the Ocean Currents Explorer 1. The first thing you're going to want to do is draw what you just saw. Okay, you can go ahead and skip the data table at the top. We're not going to worry about that. That's just showing that the temperature creeps along the bottom, the same way that the cold currents would, but we know that it does, so we're going to move on. And the second question says, deep ocean currents occur when sea ice forms. Why does formation of sea ice cause currents to flow deep in the ocean instead of on the surface? So again, this goes to why it is that the blue water is on the bottom and not floating across the top. Okay, and it actually isn't because of the foam, so just keep that in mind. Number 3, if the cold saltwater mixture represents the ocean water around sea ice as it forms, and the room temperature aquarium water represents the surrounding ocean water, what does this model show about the formation of deep ocean currents? Okay, so that's asking you to think about how this would translate to what happens in the real ocean, just like we talked about in class. Number 4 is asking you to color in a map. So if you were doing this on paper, it would look like this. This is very exciting, I'm sure. There you go. Okay, so very similar to the one that is posted in Google Classroom, except that the one in Google Classroom is already colored for you. So check Google Classroom for the map that's posted with it. It'll look a lot like this. And it's just asking you to, for number 5, what latitude does the current rise back to the surface? So you're looking for the spot within there. There's actually 2 spots where it rises back to the surface, but there's one in particular that's really obvious, and it's central. What energy source is heating the water in the current? Okay, that's talking about in the map, like out in the real world. That's not talking about our particular demonstration here. And then number 7 says the global conveyor belt moves thermal energy around the globe. What type of thermal energy transfer is occurring? So it's asking you to talk about what's happening. You know, where is the heat coming from and where is it being moved to? Okay. And that's it. Just those 7 questions, and then you're good to go. There is a CER with this. We're going to talk about that on day 2. Okay. Have a great day.